I'm a senior lecturer in the School of Engineering at the University of Waikato. My research involves the application of heat transfer and thermodynamic analysis to practical problems such as calculating the time required for a food product to cool or calculating the amount of heat absorbed in a solar hot water panel. We develop mathematical models of the heat flows that occur in thermal processes that allow us to calculate things like the heat load and cooling time. Refrigeration consumes a large quantity of energy, and a lot of New Zealand exports are exported in the frozen or chilled state. So there's obviously an incentive for industry to minimise the energy consumption, but at the same time we have to ensure that the quality and safety of the food product is not compromised. For example, if we cool lamb too fast, it will get tough, but if we don't cool it fast enough, mould may grow at the surface. And in both those cases, you won't be able to sell the meat at the final destination. The model, though, can only be as accurate as the input data. So another big part of my research is measuring important data that is used as inputs for these models and also modelling it. Mathematical modelling typically involves some trade-off between accuracy and complexity. So what we try to do is find the simplest model that will give us the desired accuracy based on the minimum of input data and doesn't take too long to solve. With the development of refrigeration technology, we always have to adapt our models. We also find that the variety of products being cooled is increasing, and also consumers have changing demands. But at the same time, we are helped by computing power increasing, and modelling knowledge expertise is also increasing, so we're able to handle more and more complex problems. So I'm working with my colleagues to develop new approaches, new modelling techniques to tackle these sorts of problems to ensure that New Zealand remains competitive as a food export nation.